Yes, children. Good morning, children. This is your chemistry teacher Murali Krishna. Today I am going to explain the new lesson, that is classification of elements and periodicity in properties. In this lesson, what we are going to learn, what is the basis for the classification of elements and the trends of the periodic properties in a group and period, how the periodic properties they will change, that we are going to learn. And it is the very important chapter. Why? Because here we are going to learn about the elements, right? Now let me start the lesson. Right here in this chapter, how the elements are classified, that is based on the modern periodic law. Modern periodic law, right? That is the physical and chemical properties. The physical and chemical properties of the elements. The physical and chemical properties of the elements are the periodic functions. Periodic functions of their atomic number. That means based on the atomic number, the modern periodic table was designed. Right? This is called modern periodic law, proposed by Moseley. Moseley's modern periodic table. Moseley's modern periodic table is developed based on this modern periodic law. That is nothing but the physical and chemical properties of elements are the periodic functions of their atomic number. Based on the atomic number of the elements, Moseley classified the elements into some different groups and periods. That we will see now. Right? Now I am drawing the Moseley's modern periodic table. Right? The first element in the periodic table is hydrogen, and the next element is helium. Right? Hydrogen atomic number 1, helium 2, lithium 3, beryllium 4. Right? Next, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. Next atomic number, sodium 11, magnesium 12. Right? Aluminium 13, silicon 14, right? Phosphorus 15, sulfur 16, chlorine 17, argon 18. Right? Potassium 19, calcium 20, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. See, while drawing the modern periodic table, this way you need to remember, this way you need to write. Right, children? Now, this way, the long form of the periodic table, you can find the long form of the periodic table. You can find the long form of the periodic table, and the remaining elements how to fill I will show you. How to remember. Right. Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Beryllium, magnesium, calcium, strontium, barium, radium. Right? Boron, aluminum, gallium, indium, thulium. Carbon, silicon, germanium, tin, lead. Hydrogen, phosphorus, arsenic, antimony, bismuth. Oxygen, sulfur, selenium, polonium. Fluorine, bromine, iodine, aspartame. Helium, neon, argon, krypton, xenon, radon. This way you can write the elements. This is the long form of the periodic table. And how these elements are classified and all we are going to see now. Right? If you look at the modern periodic table, in the bottom of the periodic table also you can see the two horizontal rows. You can see two horizontal rows. One is lanthanides and the second one is actinides. Right? Right, children, at least 30 elements you need to learn, and first only I have shown how to write 1 to 30 elements. The remaining elements you need to learn according to their group number and period number. Okay, we'll see. Now here, this horizontal rows are called there. Horizontal rows are there here. First horizontal row, right? First row, second row, right? Third row, fourth row, fifth row, sixth row, seventh row. These horizontal rows are called periods. These are called periods, right? Now here I will write. Horizontal rows are periods. Horizontal rows are periods. Now total how many periods are there? 7 periods are there. Check here. First period, second period, third period, fourth period, fifth period, sixth period, seventh period. Right? And this sixth and seventh period, this lanthanides will come under sixth period and this actinide will come under seventh period. Right? So you can find out only 7 periods in the periodic table. And what about the remaining vertical columns? Vertical columns are called groups. So this is the first vertical column. First vertical column, second vertical column, like this. First vertical column, second vertical column, third vertical column, fourth, fifth vertical column, sixth, seventh, 8, 9, 10, 11, 12, 13th vertical column, 14th vertical column, 15th vertical column, 16th vertical column, 17th vertical column, 18th vertical column. These vertical columns are called groups. Vertical columns are groups. So how many groups are there? You can find out 18 groups. This is the basic information what I am giving. So what are groups? Vertical columns are groups. Vertical columns, like these vertical columns are called groups. Okay, horizontal rows are called periods. So in the modern periodic table, how many groups and how many periods are there? 18 groups and 7 periods. 18 groups and 7 periods are present in the modern periodic table. This is also called long form of the periodic table or mostly modern periodic table. Modern periodic table or long form of the periodic table. Right? In this periodic table, the elements are classified depending upon their chemical properties also. Right? And the differentiating electron enter into which orbital? The differentiating electron enters into which orbital? Based on that also these elements are classified, right? Now we'll see the classification of the elements into groups. First we'll see the classification of elements into groups. That is S block elements. These first two groups are called S block elements. S block elements. Right, children? S block elements. Right? Now, these elements are called P block elements. First two groups are called S block elements, and 13th to 18th group are called P block elements. Yes, P block elements. And in between the S block and P block, these elements are called B block elements. And last is the two horizontal rows which are placed at the bottom of the periodic table. They are considered as F block elements. Now total how many blocks? S block, P block, D block, F block. Total 4 blocks. Yeah. Why these elements are called S block elements? Means the differentiating electron or last electron enters into S subshell or S orbital. The last electron is entering into S subshell or S orbital. That is why these elements are kept as S block elements. Now let me write the electronic configuration of sodium. Sodium atomic number 11. Electronic configuration 1s2, 2s2, 2p6, 3s1. This is the electronic configuration. Let me check whether it is correct or not. 2 plus 2, 4, 4 plus 6, 10, 10 plus 1, 11. So total 11 electrons are there. Yes, this is the correct electronic configuration. This last shell is called valency shell. In the valency shell, the last electron is present in the third shell of S subshell of S orbital in that one electron. That means last electron belongs to S orbital. So sodium belongs to S orbital. Even you can find out these elements, all these elements have the electronic configuration. The general electronic configuration of these elements are these elements are NS1 and these group elements are NS2. So N means orbit number or shell number 1s1, 2s1, 3s1, 4s1 like that. So these are all elements will have one electron in the S subshell. So this is also called first group element, and this is the special name what we have given is S block elements. So based on the electronic configuration, which group we can say? This is first group. Why it is called first group? One electron is present in the S block element. So S orbital. So it is first group element. This is second group element. Right. You come to this elements from 13th to 18th groups. 13th to 18th groups. Here in the valency shell, we will write the electronic configuration of boron. Boron atomic number 5. Electronic configuration 1s2, 2s2, 2p1. In the valency shell, 3 electrons are present. You see, second shell is the valency shell. S may 2 electrons are present, and in P 1 electron is present. Total 3 electrons. So 13th group or third group. I can say third group. 13th group or third group. 14th group or fourth group. If you write the electronic configuration, you will come to know exactly. So in this, the electronic configuration is always NS2, NP1, 2, NS2, NP6. See for example carbon. You take carbon electronic, carbon atomic number 6 electronic configuration 1s2, 2s2, 2p2. So 2s2, 2p2. ns2, np1. 2s2, 2p1. 3s2, 3p1. Like that 2s2, 2p2. So these elements, these p block elements having the electronic configuration, general electronic configuration ns2, np1 to ns2, np6. Till here you can find the electronic configuration ns2, np1 to ns2, np6. Why these are called p block element means you can see the last electron is entering into p subshell. So p block. The same way the differentiating electron into d block, then these are called d block elements. The differentiating electron enters into d orbital means d block. D block electronic configuration. What is the general d block electronic configuration? N minus 1 d 1 to 10 ns 1 r. This is the d block elements general electronic configuration. So if you see scandium electronic configuration, okay, scandium electronic configuration, last electronic configuration 3d1 4s2, 3d1 4s2. Sir, what is this 3d 4s3? Third shell, fourth shell. So which are the electron? In these d orbitals, the last electron is entering into n minus 1 d, means n value 4, n value 4 here, n minus 1 means 3. So the differentiating electrons enter into inner orbital. We can say inner means inside, inner orbital, that is 3d orbital. In scandium case 3d orbital. So in the d block elements, the differentiating electrons enter into inner d orbital. That is why the general electronic configuration is n minus 1 d 1 to 10 ns 1 to 2. And when you look at the f block element, the general valence shell electronic configuration is n minus 3 of 1 to 14, n minus 1 to 0 comma 1 ns2. This is the general valence shell electronic configuration. So now you might have understood about the classification of elements into blocks. S block. First, these two vertical columns are called S block, and these elements are called P block. And between S block and P block, middle elements are called D block. And in the bottom of the periodic table, the elements are called F block elements. And based on their chemical reactivity, also the elements are classified into 4 groups, right? They are representative elements, okay. Noble gases or inert gases, transition elements, last one, fourth one, inner transition elements, right children? Now I will explain why they are called representative elements. So based on the chemical reactivity, the elements are classified into 4 ways: representative elements, noble gases or inert gases, transition elements and inner transition elements. Representative means important. Even in our normal day-to-day life also, we will select some representatives. Means they are important. Representatives in the sense they are important. Which are important in the periodic table means this S block elements, these two vertical columns, these two, and these 13 to 17, not 18, 13 to 17. These are called representative elements. Representative elements means first 2 groups, and then in P block elements up to 17, 13 to 17. These many are called representative elements. Understood? Representative element means except 18th group, except 18th group, first, second, 13th, 14th, 15th, 16th, 17th. These are called representative elements. Why? Because they are more reactive towards the reactions. Right? They show the more reactivity, they are considered as representative elements. And this helium, neon, argon, krypton, xenon, this radon, noble gases are inert gases. This group is called 18th group or zero group also we will say. 18th group or zero group. This 18th group elements are called noble gases or inert gases. Noble gases or inert gases. Only 18th group elements are called noble gases. And just now I explained about the D block. The same D block are nothing but transition elements. And F block elements are nothing but inner transition elements. Transition means changing. So when the S block elements and between the S block elements and the P block elements, the elements are there. And the periodic properties also, when it is the properties of these D block elements are also changing. That is why the name has come, transition element. Transition means change. When the elements, S block elements are converted into P block elements, at that time in between the S block and P block the elements are placed. That is why these elements are called transition elements and inner transition elements. Inner transition elements are nothing but F block elements. This is the brief study of classification of elements. Right? Thank you.